Welcome to this tutorial on init containers in Kubernetes. Init containers are a powerful feature that help us prepare our pods before the main application starts running. They handle pre-main container setup tasks, ensuring everything is ready for our application to work properly. Init containers are specialized containers that run and complete before any application containers start in a pod. Think of them as preparation workers that handle initialization tasks that shouldn't be part of the main application container. They set up the environment, check dependencies, and ensure everything is ready before your main application begins. Init containers have three key characteristics that make them unique. First, they run sequentially in the order they're defined in your pod specification. Second, each init container must complete successfully before the next one starts. And third, all init containers must finish their work before any app containers can start running. Let's understand how init containers differ from app containers. Init containers run to completion, meaning they execute their task and exit. They run sequentially, one after another. And they're designed for setup tasks only. In contrast, app containers run continuously throughout the pod's lifecycle. They execute in parallel with each other, and they handle the main workload of your application. Init containers are perfect for several common scenarios. You can use them to wait for services, delaying your app start until dependencies like databases are ready. They're great for setup configuration, where you generate config files from templates. You can clone repositories to fetch code or data into shared volumes, and you can register your pod with external services before the main application starts. Here's the basic structure for defining init containers in a pod specification. You start with the standard API version v1 and kind pod. In the spec section, you add an init containers field as a list. Each init container needs a name and an image, just like regular containers. Notice how the init containers section appears before the main containers section in the specification. Let's look at a practical example. This init container named wait for database uses the busybox image. It runs a shell command that repeatedly checks if the database service can be resolved using NSLOOKUP. The until loop keeps trying every 2 seconds until the database service is available. Only after this init container succeeds will the main application container start. When working with init containers, follow these best practices. Keep your init containers idempotent, meaning they can be run multiple times safely in case of restarts. Use lightweight images to reduce startup time and resource consumption. And share data with your app containers using volumes, allowing init containers to prepare files and configurations that the main application needs.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.